Hi, good morning all of you. So today we are going to study question number 5, 8 marks question, very important one from Oscillations chapter. మనం ఇంతకుముందు అనుకున్నట్లుగా ఆసిలేషన్ చాప్టర్లో 2 క్వశ్చన్స్ ఉన్నాయి మనకి. రెండిట్లో ఒకటి టైం పీరియడ్ ఆఫ్ సింపుల్ పెండ్యులమ్ మరి కంప్లీట్ చేశాము. ఇప్పుడు మనము సెకండ్ క్వశ్చన్ చూస్తున్నాం. సో వాట్ ఈస్ దిస్ సెకండ్ క్వశ్చన్? డిఫైన్స్ SHM మీన్స్ సింపుల్ హార్మోనిక్ మోషన్. సింపుల్ హార్మోనిక్ మోషన్ అంటే ఏందనేది మనం డిఫైన్ చేయాలి. అలాగే షో దట్ ద మోషన్ ఆఫ్ ప్రొజెక్షన్ ఆఫ్ ఎ పార్టికల్ performing uniform circular motion on any diameter is simple harmonic. Means what? See, suppose ఇది ఒక సర్క్యులర్ పాత్ అనుకోండి, దీనిపైన సర్కంఫరెన్స్ పైన ఒక పార్టికల్ ఇలా మూవ్ అవుతూ ఒక ఆసిలేషన్ కంప్లీట్ చేస్తూ ఉంది. అలాంటప్పుడు దాని నీడ షాడో ప్రొజెక్షన్ అంటాం దీన్ని. అది కూడా ఏమవుతుందంటే ఈ పార్టికల్ ఎలా ఎలా కదులుతుందో అలా డయామీటర్ మీద కదులుతూ ఉంటుంది. ఇలా పార్టికల్ ఇలా కంప్లీట్ చేస్తే ఈ షాడో ప్రొజెక్షన్ ఏదైతే ఉందో ఈ విధంగా సింపుల్ హార్మోనిక్ మోషన్ని ఎగ్జిబిట్ చేస్తుంది అని చూపించాలి. సో సింపుల్ హార్మోనిక్ మోషన్లో ఉన్నటువంటి ఆబ్జెక్ట్కి మ్యాథమెటికల్ ఫామ్ ఏంటి ఎగ్జిబిట్ చేస్తుంది అని చెప్పడానికి ఏ ప్రపోర్షనల్ టు -y అని ప్రూవ్ చేయాలి. ఇది ప్రూవ్ చేస్తే మనం పాత్ ఆఫ్ ప్రొజెక్షన్ ఆఫ్ ఏ పార్టికల్ విచ్ ఈస్ పర్ఫార్మింగ్ సర్క్యులర్ మోషన్ ఈజ్ SHM అని ప్రూవ్ చేసినట్టు అవుతుంది. సో లెట్ us define first what is simple హార్మోనిక్ మోషన్. చూడండి, డెఫినేషన్ ఏంటంటే మనకు ఆల్రెడీ తెలుసు, డెఫినేషన్కి 2 మార్క్స్ ఉంటాయి. ఓకే, సో 4 కండిషన్స్ మనం చెప్పాలి. ఓకే, ఇఫ్ ఎనీ పార్టికల్ సాటిస్ఫైయింగ్ ఫాలోయింగ్ కండిషన్స్ can be considered as it is performing simple harmonic motion. So first point ఏంటి? The motion should be to and fro. The motion should be to and fro. That means the particle has to move both sides likewise, towards right hand and towards left hand, and then mean position, to and fro. And acceleration should be, A means acceleration should be directly proportional to displacement. Y means displacement. And acceleration and displacement both are opposite to each other. Both are opposite to each other. And acceleration is always directed towards mean position. Directed towards mean position. If any particle following these 4 conditions, then we say that the particle is performing SHM. So for this definition you will get 2 marks. Okay, so this is what we have. So the motion should be to and fro, mean position nunchi itu atu kadultu undali. Acceleration and displacement both are directly proportional. See here, acceleration is depending on displacement. అంటే ఏంటి? ఫర్ ఎగ్జాంపుల్ ఆబ్జెక్ట్ ఇక్కడ నుంచి ఇక్కడికి డిస్ప్లేస్ అయింది ఒక 8 సెంటీమీటర్స్ అనుకుందాం. అప్పుడు యాక్సిలరేషన్ 2 మీటర్ పర్ సెకండ్ స్క్వేర్ ఉంది అనుకుందాం. నెక్స్ట్ టైం ఒక 12 సెంటీమీటర్స్ మూవ్ అయింది అనుకుందాం. అప్పుడు యాక్సిలరేషన్ ఏమవుతుంది? పెరుగుతుంది 5 మీటర్ పర్ సెకండ్ స్క్వేర్. ఇలా డిస్ప్లేస్మెంట్ పెరిగితే యాక్సిలరేషన్ పెరుగుతుంది. ఎందుకు పెరుగుతుంది? బికాస్ ఇట్ హ్యాస్ టు బ్రింగ్ దట్ ఆబ్జెక్ట్ టువర్డ్స్ మెయిన్ పొజిషన్. ఆబ్జెక్ట్ని తీసుకురావాలి, మెయిన్ పొజిషన్కి తీసుకురావాలి, అందుకని యాక్సిలరేషన్ పెరుగుతుంది అన్నట్టు. So as the displacement increases, acceleration also increases, but in opposite direction. Okay, and acceleration is always towards mean position వైపే ఉంటుంది. So this is the definition. Okay, for this we will get 2 marks. Now let us prove in case of the object moving along the circumference of circle. So for this, see, suppose this is a circular path, okay, and these are the two different radius. Now say for example at point P the object is, okay, and this is origin O, okay, or otherwise let me take a little bit down, okay. So at point P, right, and this radius I am considering it as A, right, I am considering it as A. And see, at point P the object is staying, so you need to write some description here. What is that? Consider a particle moving on circumference of circle. Circumference initially at point P. Initially at point P. After some time, T, it is at X. It is at X. ఇక్కడ ఒక X అనే పాయింట్ ఉంది అనుకుందాం, ఓకే. ఈ X అనే పాయింట్ దగ్గరికి షిఫ్ట్ అయ్యింది అనుకుందాం. పార్టికల్ ఏమైంది? X అనే పాయింట్ దగ్గరికి వెళ్ళింది. ఇప్పుడు చూడండి, దిస్ విల్ బికమ్ యాంగులర్ డిస్ప్లేస్మెంట్. This will become angular displacement. At the same time, as the particle, whenever it is at point P, its shadow or projection is at point O. Now the particle shifted to point X, so its shadow will shift somewhere here, point M. Okay. Somewhere. So this will be the projections displacement y. Projection already, shadow already, no issue. But see, mx and op both are what? Parallel lines. A line is intersecting like this. So these two are forming as alternate angles. So these alternate angles are always same. And we know this ox is also radius. So we label it as E. Okay. Right, after some time t, it is at x. So the angular displacement is theta. But from definition of angular velocity v is equals to, omega is equals to what? Angular displacement by time. So omega t is equals to theta. That means theta is equals to what? Omega t. Theta is equals to omega t. Okay. So this is how we bring angular displacement. Okay. Now, okay, note it down till this point. Now, from the diagram OMX, there is a triangle. From right angle triangle OMX, we can write sine theta is equals to, sine theta means what? Mathematical definition, opposite side by hypotenuse. Opposite side by hypotenuse. So from figure, sine theta is equals to what? This is theta. Opposite side is OM. Hypotenuse is OX. So sine theta is equal to, OM means how much? Y. Okay, OX is A. So if you want Y, bring A this side. So what happens? A sine theta is equals to Y. Therefore Y is equals to A sine theta. Okay, and where Y is equals to A sine omega t, because theta means omega t. So this is equation number 1. This is the displacement equation. Okay, so from this diagram we are derived the displacement equation. Actually what we need to prove? we need to prove that acceleration is directly proportional to y. That means from the displacement we can derive acceleration, because if you make time derivative for displacement, you will get velocity. If you make again time derivative for velocity, you will get acceleration. Okay, so first y derive చేసుకోవాలి. ఇక్కడ డయాగ్రామ్కి 1 మార్క్ ఉంటుంది. ఓకే, మీరు ఇది ప్రూవ్ చేసినందుకు ఒక 1 మార్క్ ఉంటుంది, 2 మార్క్స్, ఇంకా 4 మార్క్స్ ఉన్నాయి. సో వి కనుక్కున్నందుకు 2 మార్క్స్, ఫైనల్గా యాక్సిలరేషన్ కనుక్కుని SHM అని చెప్పినందుకు 2 మార్క్స్. ఓకే, నౌ లెట్ us take this equation. Okay, note it down. I am clearing it. So our first equation is y is equals to a sin omega t. This is our equation 1. Now both sides do time derivative. dy by dt is equals to d by dt of a sin omega t. So rate of change of displacement, and what? Velocity. So here a, as the particle moving, the radius is not at all changing, so we are keeping it outside. Actually here a means amplitude, right? Now do the time derivative for sine value, sine omega t. So again you have formulas. D by dt of sine theta is equals to cos theta. These are formulas. Derivative sine theta is equals to cos theta. So v is equals to a cos omega t, and again you have to do derivation for angle as well. So d by dt of omega t. So v is equals to a cos omega t. See, this omega is constant, we are keeping it out, and dt by dt cancel. So bring this omega this side, a omega cos omega t. This is number equation 2. Okay, so if you do this till this point, you are going to get 4 marks, and the 2 marks you have got. Now you got velocity. If you do time derivative for velocity, you will get acceleration, and thereby we can prove this easily. Okay, note it down. Now what is our equation? V is equals to a omega cos omega t. A omega cos omega t. Right, derivative cos theta is equals to minus sin theta. This is the formula. So do the time derivative again. dv by dt, d by dt of a omega cos omega t. So time derivative of velocity gives you acceleration. A omega is outside, constant. Okay, d by dt of cos omega t. We know the formula. A omega minus, see this is minus now, because derivative cos means minus sign. So sin omega t, and again do the time derivative for omega t. So a is equals to minus a omega sin omega t. Omega keep outside, dt by dt cancel. So a is equals to minus a omega into omega, omega square sin omega t. So a is equals to minus omega square a sin omega t. I am writing, just I am interchanging a and omega square. See, but from 1 we know, equation 1 ఏంటి మనకు, y is equals to a sin omega t కదా ఈక్వేషన్. అంటే a sin omega t బదులు నేను ఏం రాయొచ్చు, y రాయొచ్చు. సో a is equals to minus omega square y. therefore ఇది omega square కాన్స్టెంట్ ఇక్కడ ఈక్వల్ టు ఉంది, సో ప్రపోర్షనాలిటీగా రాసుకోండి, a proportional to minus y, which is the required equation. That means the particle is exhibiting simple harmonic motion. Here the projection. So the projection is exhibiting SHM. So this is what we need to prove. So simple. Okay, you have to go with time derivation 2 times, for displacement once and another time velocity. You will get acceleration, and that acceleration is directly proportional to displacement. This is what the definition of simple harmonic motion. So in this way we can complete this question. Here the key concept is, however you are writing definition, that is not at all bothering, but you have to keep in mind the diagram. If you practice diagram thoroughly, you will understand, because everything we are deriving from the diagram itself. See, we are considering that there is a circular path. On that path there is a particle P, okay, moving like this in simple circular motion, but its shadow is performing simple harmonic motion. Particle is performing circular motion, its shadow or projection is performing what? Simple harmonic motion. So to show that simple harmonic motion, we must show a proportional to minus y. So first, initially the particle is at point P, so its projection is at point 2. But after some time, the particle shifted to point X and its projection shifted to point M. So the particle's angular displacement is theta, which is omega t, and the projection's displacement is y. So from that, this triangle is very much important. From here, we are deriving sine theta value. So sine theta is equals to what? Okay, opposite side by hypotenuse. So here we are getting sine theta is equals to y by a. So y is equals to a sine theta, but theta means what? A sine omega t. This is what we are proving. Once this displacement equation, okay, we achieved, we can easily make derivation, time derivation for it. From there you will get velocity equation, and again time derivative. From there you will get acceleration equation, this one. Okay, after coming to this point, a is equals to minus omega square, a sine omega t. Again you go to first equation, y is equals to a sine omega t, where a sine omega t means y. So y, a is equals to minus omega square y, which is nothing but a proportional to minus. Okay, so practice 2 to 3 times, then it is very easy. So the remaining 2 questions we will complete as early as possible. So out of 2 questions, you whatever the questions, out of 3 questions, we have completed 2 questions. So there you have 3, here you have 2. Out of 5, 2 questions are definitely going to come. There is no need to go for third one also. But if you read these 5 questions thoroughly, you will get 16 marks. Okay, that is up to you. Thank you.